So today I thought I'd do a quick session on hash columns in SQL. So hash columns are used to search for data very fast and also to compare data, and it can even be used with indexing to search for data and to do it at a very high speed. So let's see. So how can we do this? Because like we all have come across instances where we have to compare several fields to ascertain that a particular row of data is unique. So in cases like that, we can use hash columns. So you can think of hash columns as digital fingerprints of your data. So we can use several fields and create a unique field to identify a particular row of data, and this column can be used to uniquely identify a row and to compare the data which is held in this row with for example with other data which we might bring in from outside. So if you have the same input, you'll get the same hash value. So if the inputs are of course different, the hash value will be different as well. So this is the perfect way to quickly compare large sets of data without comparing each and every column to ensure that a particular row of data is unique. So let's see, like why do we use hash columns? So we use hash column to compare data or to compare data at a higher speed. Right? So why do we use hash columns? Because of the sheer speed it offers us. Because we can compare data very fast, and also like if we have a particular row of data and we say a set of fields that frequently change, and we instead of saying, oh, did this field change, did this field change in this row, we can use a hash. So if any of those fields change, which are fields which frequently change, using the hash value we can identify that data has been modified. And also sometimes there can be corrupt data. So how do we ensure that data in a particular row is not corrupt? By using its hash value. So if we can regenerate the hash value using the same set of data, the row of data is not corrupt. And also we all of us use ETL processors in most of our applications. So why do we need to process rows which haven't changed? So hash columns can be very useful in identifying uh, these rows of data which haven't changed, so we can just skip them during processing. So we all know that indexing helps us to search data fast, and if you use a hash column, because it includes several columns, you can search even faster. So hash columns are implemented in different databases in different ways. In SQL Server, we use a function called hash bytes. In MySQL, we have several other functions. So each database has its unique way of creating these hash formats for us. So let's see an example. So for example, we say I have a customer table and I'm going to create a hash value or a hash field based on the name, email, and the phone number. So so all three will using all three of these columns, I'm going to create a hash field. So if any of these change, I know, if any of these change, of course the hash value won't be the same. So we can easily detect that there has been some changes along the lines. So how do I create this particular hash column? So I will mention these fields to be included, and then I will, based on the database, I will mention which function has to be used, and then we get a hash result, which takes into consideration all these fields. So like if I want to compare a particular row of data and see whether it has changed or not, So I can compare the stored hash against the hash which I will generate based on the input data. So it will allow me to uh, check whether the data has changed very quickly rather than comparing. Oh, I cannot. In other words, in this case, which is a very simple example, I can check first name is it equal to the first name it is input, last name is it equal to the last name that was input. So that is cumbersome, time consuming, and it's not doable if we have many fields, and it's consuming, time consuming, and so it will also hit the performance. So in cases like that, a hash column comes in very handy, especially in cases where we have loads of data to be compared. So of course, like any tool, it's a double-edged sword. So you have to be consistent in the fields you use, the order you use these fields in when creating a hash column, and also the way you use nulls will also decide how your uh, uh, hash column behaves. So you have to be very careful, and also you have to use an algorithm uh, which balances of basically you have to balance of, trade off, because of course using uh, a hash column will have some performance impact while creating records and stuff like that. So choose your algorithms very wisely. And indexing your hash columns can help you to look up data very fast. And also just remember, there is like a very rare chance that there can be collisions as well at times. But you have to remember, mostly is whatever you put in, garbage out. So you have to be very careful into what you put into creating into what you input in order to create these hash columns. So wrapping up, what we have to say is like hash columns can be very useful in comparing data very fast, and also to identify uh, data duplicates, like duplicate rows of data. And also it can be very useful in ETL processes to skip data that haven't been updated. So I think we all should try out hash these hash fields when we have to deal with lots of data. Thank you.